The silence of space isn't just empty, it's alive with whispers of the unknown, a chorus of cosmic horrors waiting to be heard. Picture this, floating in the endless void, surrounded by an abyss so vast it defies comprehension, when suddenly a sound. Not the familiar hum of stars or the gentle pulse of distant galaxies, but something darker, a ripple in the fabric of reality itself, hinting at forces beyond our understanding. This is the universe's dark side, a shadow realm where the laws of physics twist into nightmares, and the stars themselves hide secrets too terrifying to name. You've gazed at the night sky, marveled at its beauty, but what if I told you that beyond the glittering constellations lies a world of unspeakable phenomena? Black holes that don't just consume light but tear time apart, ghostly remnants of dead stars that scream across the cosmos, planets where the very air is poison and storms rage with the fury of 1,000 suns. These aren't just scientific curiosities, they're the stuff of cosmic dread, reminders that the universe is far stranger, far more hostile than we ever dared to imagine. And today, we're venturing into that darkness. Over the next 25 revelations, we'll peel back the veneer of the familiar cosmos to expose the terrors lurking just beneath. From rogue planets drifting through the eternal night to galaxies that devour their own, each discovery will rewrite what you thought you knew about space. This isn't just a journey, it's a descent into the unknown, a confrontation with the sheer scale of our insignificance in the face of the universe's indifference. So steel yourself, what you're about to witness will haunt your dreams long after the screen fades to black. The cosmos is calling, and it doesn't care if you're ready. The Boötes Void isn't just empty space, it's a cosmic anomaly so vast, so eerily barren, it chills astronomers to the core. Stretching over 330 million light-years across, this colossal desert of darkness holds almost no galaxies, a void so immense you could fit 60 Milky Ways side by side and still drown in the nothingness. Scientists call it the Great Nothing, a haunting name for a place where the universe seems to have forgotten its own rules. Imagine floating through this abyss, no stars, no planets, just an endless stretch of black so profound it feels like the cosmos has ripped a hole in itself. What makes the Boötes Void truly unsettling isn't just its emptiness, but the questions it forces us to confront. How does a region this large end up with almost no galaxies? The laws of physics suggest matter should be spread somewhat evenly, yet here, reality itself seems broken. Some theories whisper of ancient cosmic forces, of collisions between universes we can't comprehend. Others suggest something even darker, that the void isn't empty at all, but hiding something our instruments can't detect, a shadow dimension. A graveyard of dead galaxies, the possibilities gnaw at the edges of our understanding. And then there's the scale. If Earth sat at the center of the Boötes Void, humanity wouldn't have even known other galaxies existed until the 1960s. The nearest star systems would be so distant, our night sky would be a perfect, unbroken black. It's a reminder of how fragile our place in the universe truly is, how easily we could vanish into the endless dark unnoticed. This isn't just a scientific curiosity, it's a cosmic horror story written in negative space, a reminder that the universe doesn't just contain mysteries, it is the mystery. And the Boötes Void, it's the ultimate punchline, the universe whispering, you know nothing at all. Black holes are terrifying enough when they stay put, but what happens when they go rogue? These invisible predators don't just lurk at the centers of galaxies. Some break free, hurtling through the cosmos like cosmic sharks, stripping stars bare and warping space-time in their wake. Take MOA 2011 BLG 191, a rogue black hole discovered drifting silently through the Milky Way, its presence betrayed only by the way it bent the light of a distant star like a funhouse mirror. At 7 times the mass of our Sun, it's a monster adrift, and astronomers estimate there could be millions more like it, each one a ghost in the interstellar darkness. The real terror, we might not see them coming. Unlike stars, black holes emit no light, no warning. Their gravitational pull is so strong, not even photons can escape, meaning one could slip into our solar system undetected until it's too late. Picture this: planets wrenched from their orbits, the sun's light stretching into grotesque arcs as space-time itself twists. Long before it consumed us, the subtle distortions in the paths of comets or the wobble of nearby stars might be our only clues, a haunting game of celestial pinball with stakes too high to fathom. And here's the cruel twist of physics. Even if a rogue black hole passed harmlessly through our solar system, its gravity could still fling Earth into the freezing void or hurl us straight into the sun. No apocalyptic fireball, no dramatic collision, just a nudge, precise and pitiless, rewriting our fate in an instant. These aren't just theoretical horrors. In 2022, Hubble confirmed the first isolated stellar mass black hole, drifting just 5,000 light-years away. That's cosmically next door. The universe is teeming with these unseen wanderers, and every single one is a reminder: we're not just living in a galaxy, we're living in a minefield. We think of galaxies as eternal islands of light, stable and unchanging, but the truth is far more violent. Right now, the Milky Way is locked in a death spiral with our closest neighbor, Andromeda, two cosmic titans destined to tear each other apart in a collision lasting billions of years. This isn't science fiction. Simulations show the horrifying beauty of galactic cannibalism. Stars ripped from their orbits like confetti in a hurricane, entire solar systems flung into the abyss, and the night sky warping into unrecognizable shapes as gravity reshapes everything we know. Imagine standing on Earth 4 billion years from now, looking up as Andromeda looms larger every night, not as a faint smudge of light, but a monstrous smear of stars swallowing the heavens. The two galaxies won't just collide, they'll entwine in a grotesque dance, their supermassive black holes circling each other like predators sizing up their prey. Stars won't physically crash, space is too vast for that, but gravity's invisible hand will hurl them into chaos. Some will be ejected into the void, doomed to drift alone forever. Others will plunge toward the new galaxy's core, fuel for the ravenous black holes waiting there. And here's the cruel irony: Earth might survive. Our planet could endure the collision, but the price would be isolation. The Sun, flung to the outskirts of this hybrid galaxy, would leave our descendants beneath a sky stripped of familiar constellations, a hollow victory in a battle between giants. This isn't some distant abstraction. Hubble's images already show Andromeda's halo, a shroud of gas and orphaned stars from past galactic feasts, proof that cannibalism is written into the universe's DNA. We're not just watching a future apocalypse, we're living in the calm before the storm. Death should be final, but in the cosmos, even stars refuse to stay dead. Meet LP 4365, a cosmic zombie staggering through the Milky Way at nearly 2 million miles per hour, a radioactive relic of a supernova that should have destroyed it completely. This white dwarf didn't just survive its own violent death. It was catapulted across the galaxy like shrapnel from a celestial grenade, leaving astronomers baffled. How does a star cheat death, and what happens when these unstable husks wander too close to other stellar corpses, risking a chain reaction of apocalyptic explosions? The horror lies in the process. When a white dwarf steals too much matter from a companion star, it triggers a thermonuclear supernova, a blast so powerful it should vaporize the star entirely. Yet LP 4365 endured. Its outer layers scorched away to reveal a monstrous core of neon, oxygen, and magnesium, elements forged in the heart of the explosion itself. This isn't just a dead star, it's a walking bomb, leaking intense radiation as it careens through space. Scientists call these objects partially burnt runaway stars, but that clinical term hides the truth. They're ticking time capsules of stellar violence, their very existence defying the laws we thought governed supernova. Now imagine one drifting into a crowded stellar neighborhood. White dwarfs are already volatile, but a zombie star's radioactive instability could ignite nearby corpses like matches in a powder keg. The result, a domino effect of supernova, each explosion hurling more shrapnel into the void, potentially ripping through star systems with unimaginable force. In 2021, researchers discovered LP 4365 wasn't alone. Other survivor stars were spotted, each with bizarre chemical signatures hinting at similar traumatic past. The galaxy might be littered with these undead wanderers, each one a reminder that even in death, stars can be more dangerous than alive, the cruelest twist. We're made of their ashes, the elements in your bones, the iron in your blood. They were forged in stellar explosions like the one that birthed LP 4365. These zombie stars aren't just threats, they're grotesque mirrors showing us how easily the universe recycles destruction into creation. And somewhere out there, another rogue remnant is hurtling through the dark, a radioactive ghost carrying the blueprint of our own atomic origins and the seeds of future apocalypses we can't yet see. The universe should be teeming with life, with billions of galaxies, each holding billions of stars. The numbers scream that we shouldn't be alone, so where is everybody? This is the Fermi Paradox, the haunting disconnect between the high probability of alien civilizations and the eerie silence that greets us. But there's a darker answer lurking in that silence, one that chills scientists to the bone. What if advanced civilizations don't last long enough to be heard? Consider the Great Filter Theory, a cosmic bottleneck that wipes out civilizations before they can spread beyond their home worlds. Maybe it's the rise of artificial intelligence turning on its creators, or climate collapse, or nuclear war. The terrifying implication, humanity might not have passed the filter yet. We could be standing on the precipice, unaware that the same forces that silence the cosmos are already at work here. The universe isn't quiet because life is rare. It's quiet because life is fleeting. Look around Earth today. How many of our own existential threats mirror potential great filters? From environmental devastation to unchecked technological growth, we're dancing on the edge of self-annihilation. And if civilizations like ours keep blinking out, the universe would remain a graveyard of untold histories, each snuffed out before they could ever reach across the stars. There's no graver warning than a sky devoid of voices. The silence isn't just a mystery, it's an obituary, one we might already be writing for ourselves. But here's the twist, the same filter that destroys could also save us. If we recognize the pattern, if we see the trap before it snaps shut, we might be the first civilization to cheat the universe's cruel odds. That's the paradox within the paradox. The darkness of the cosmos isn't just a warning, it's a challenge. One we'll either rise to meet or become another whisper lost to the void. We think of space as empty, but what if the true horror is realizing we're surrounded by something we can't see, something that outnumbers us 100 to 1? Dark matter doesn't just lurk in the shadows, it weaves the universe together with invisible threads, a cosmic spider spinning a web where galaxies are merely dewdrops caught in its grip. The Bullet Cluster offers undeniable proof, a ghostly handprint pressed against reality itself. When two galaxy clusters collided, their visible gas slammed together like a car wreck, glowing hot with X-rays. But the real shock came when astronomers mapped the gravity-distorting starlight behind them. The mass wasn't where the gas was. It had sailed right through, dragging entire galaxies with it like puppets on strings. The puppeteer, dark matter, silent and unstoppable. This isn't just some abstract puzzle for physicists, it's proof we're living in a house of mirrors. Normal matter, the stars, planets, even our bodies, makes up less than 15% of what's actually out there. The rest is this invisible puppeteer, its gravity bending light into eerie arcs, spinning galaxies faster than they should be able to spin without flying apart. Imagine swinging a bucket of water in circles. only to realize an unseen force keeps adding more water, more weight, defying every law you thought you knew. That's dark matter's grip on reality, and the web it weaves is alive. Supercomputer simulations reveal filaments of dark matter stretching across billions of light years, a skeletal framework where galaxies cluster like mold on rotting wood. We're not just floating in space, we're trapped in the veins of something vast and ancient. The cruelest joke: we'll never touch it, never see it, never even prove what it truly is. It tugs at stars, warps space-time, yet slips through our hands like smoke. Every galaxy, every star, every atom in your body dances to the tune of something we can't perceive. The universe isn't just stranger than we imagine. It's stranger than we can imagine, and dark matter, it's the architect of that strangeness, the silent god we'll spend centuries trying and failing to understand. At the heart of some of the oldest galaxies, cosmic monsters lie in wait: quasars, the ravenous cores of ancient giants, now reduced to engines of pure destruction. These aren't just dead relics, they're cosmic flamethrowers capable of shooting jets of superheated plasma millions of light years long, beams so powerful they could scour entire galaxies clean of life in a single sweep. And the worst part, one of these death rays could already be aimed at us, silently traversing the void, its arrival clock ticking down without us even knowing. Picture a quasar as a black hole on steroids, feeding so voraciously it chokes on its own meal. As matter spirals inward at nearly the speed of light, friction heats it to billions of degrees, transforming it into a swirling maelstrom of energy. But instead of swallowing everything, some quasars fire the excess back out in twin jets, narrow beams of ionized death traveling at near light speed. These aren't gentle streams, they're particle accelerators of cosmic scale, carrying enough energy to strip atmospheres from planets light years away and rip apart the DNA of any life they touch. We've seen the aftermath. In distant galaxy clusters, quasars have left scars, vast bubbles carved into intergalactic gas, testimony to eruptions so violent they reshape entire corners of the universe. One beam, dubbed the teacup for its deceptively delicate shape, stretches 200,000 light years from its source, a fossilized scream from an epoch when galaxies were young and the universe ran hot with fury. Now imagine such a beam turned toward Earth. While the odds are slim, they're not zero. Quasar activity peaked billions of years ago, but light takes time to travel, meaning a death beam fired from a distant galaxy in the early universe could still be en route, undetectable until it's already upon us. There'd be no warning, no time to react. One day, telescopes would pick up a sudden spike in gamma radiation, followed by a wave of high-energy particles shredding our magnetosphere like tissue paper. The sky itself would glow with lethal radiation, and within months Earth's surface would become uninhabitable. Yet quasars aren't just destroyers, they're also creators. Their jets seed the cosmos with heavy elements, forging the building blocks of future stars and planets. The same forces that sterilize galaxies also make life possible elsewhere, a paradox as old as the universe itself. So while we might fear these ancient death beams, we also owe our existence to the chaos they bring. The universe doesn't care about survival, it only cares about balance. And quasars, they're the ultimate enforcers of that brutal, beautiful truth. Vacuum decay isn't just a theory, it's the universe's ultimate self-destruct button, a doomsday scenario so absolute it makes black holes seem tame. Picture reality as a fragile soap bubble floating in an infinite void. For now, it's stable, but somewhere out there, a single quantum fluctuation could trigger a catastrophe. A tiny patch of space might suddenly drop into a lower energy state, unleashing a wall of annihilation that expands at the speed of light, rewriting the laws of physics as it goes. One moment, galaxies, planets, life itself exists; the next, everything is gone, erased as effortlessly as a chalkboard wiped clean. Stephen Hawking called it the universe's greatest existential threat, and the science behind it is just as chilling as it sounds. Space isn't truly empty, it seethes with quantum fields holding everything together. But if one of those fields collapsed into a more stable state, its true vacuum, the change would spread outward like a cosmic wildfire. Atoms would unravel, forces like electromagnetism and gravity would cease working as we know them, and the very fabric of space-time would rewrite itself into something unrecognizable. No explosion, no dramatic collapse, just instant, irreversible transformation into a reality where life as we understand it couldn't exist. Here's the real horror: we wouldn't see it coming. A vacuum decay bubble could already be racing toward us from some distant galaxy, and by the time its leading edge reached Earth, it would be too late. The moment light from the event reached our telescopes, the wave itself would already be here. No warning, no final moments, just the sudden, silent obliteration of everything. Some theories suggest it could start artificially too. High-energy experiments like particle colliders might, in extreme scenarios, create the perfect conditions to trigger a local collapse. The odds are astronomically low, but the stakes, they're infinite. Yet vacuum decay isn't just about destruction. It's about the unsettling fragility of existence itself. The fact that reality teeters on a knife's edge, that the universe's laws aren't set in stone but merely the most stable configuration we've stumbled into, is a humbling thought. If the Higgs field, which gives particles mass, were just slightly weaker or stronger, life might never have arisen in the first place. In a way, we're already living on borrowed time, in a cosmic house of cards that could collapse at any moment. And here's the twist: if vacuum decay is possible, it might have already happened elsewhere. The universe is vast enough that another bubble could have formed billions of years ago, expanding until it met another, erasing entire swaths of reality before we even knew they existed. The night sky's silence might not just be the absence of life, it might be the echo of countless worlds already wiped from existence. It's a theory that forces us to confront the darkest truth of all: reality isn't permanent. It's temporary, fragile, and hanging by a thread we don't even fully understand. Stars aren't just born, they're sometimes hurled across the cosmos like celestial shrapnel, and S5HVS1 is a perfect example of this cosmic violence. Clocked at over 1,600,000 kilometers per second, this hypervelocity star didn't gently drift away from its birthplace. It was catapulted by the unimaginable gravitational forces of a supermassive black hole, becoming an interstellar bullet with enough kinetic energy to devastate anything in its path. Picture the sheer power required to fling an object twice the mass of our Sun fast enough to cross the distance from New York to Los Angeles in under 2 seconds. That's not astronomy, that's celestial artillery. What makes these stars truly terrifying isn't just their speed, but their unpredictability. Most stars follow orderly orbits, but hypervelocity stars break all the rules, careening through the galaxy in chaotic trajectories. If one passed within a few light years of our solar system, its gravitational pull could yank comets from the Oort cloud, sending icy projectiles raining inward toward the inner planets. Worse yet, direct proximity could destabilize planetary orbits, turning a stable system like ours into a cosmic demolition derby. And here's the kicker: we might not see it coming until it's too late. These stars don't glow brighter as they accelerate. They're stealthy, slipping through the void with only subtle clues in their wake. The origin story of S5HVS1 reads like a cosmic horror tale. Astronomers believe it was once part of a binary system, orbiting peacefully until it wandered too close to Sagittarius, a star, the supermassive black hole at the Milky Way's heart. In a process called the Hills mechanism, its companion star was captured, while S5HVS1 was slingshotted outward at a fraction of light speed, a lone survivor of gravitational betrayal. Now it's racing toward intergalactic space, where it may eventually drift into the endless void between galaxies, a frozen relic of its violent ejection. But the true scale of destruction these stars could unleash becomes clear when we study their aftermath. In 2019, researchers discovered rogue planets, worlds torn from their parent stars, floating in the darkness. Some were likely set adrift by hypervelocity stars passing through their systems, their gravity ripping planets from stable orbits and leaving them to wander the cosmos. Imagine being on a world like that. One day, your sun vanishes, catapulted into the abyss by forces beyond comprehension, leaving you in perpetual night. Yet there's a strange beauty in these runaway stars. They carry the chemical signatures of their birthplaces, cosmic time capsules hurtling through space. By studying them, we're piecing together the violent history of our galaxy's center, where black holes play gravitational pinball with stars. And as we find more of these stellar outcasts, we're forced to confront a chilling truth. The universe isn't just vast and mysterious. It's violent, unpredictable, and utterly indifferent to the delicate balance that makes life possible. Hypervelocity stars aren't anomalies. They're reminders that chaos is woven into the fabric of the cosmos itself. Imagine a world where every satellite, every space station, even the dreams of interplanetary travel are shattered, not by war or alien invasion, but by an invisible storm of our own making. Welcome to Kessler's Syndrome, the slow-motion apocalypse that could turn Earth into a prison planet, sealed off by a swirling cage of orbital debris traveling at 17,500 miles per hour. Right now, over 120 million fragments of human trash circle our planet. Dead satellites, discarded rocket stages, even flecks of paint, each one a potential bullet capable of puncturing spacecraft hulls or crippling critical infrastructure with a single impact. The nightmare begins with a single collision. Two satellites crash, shattering into thousands of razor-sharp shards. Each new piece strikes another object, creating more debris in an explosive chain reaction. Within weeks, low Earth orbit becomes a minefield, the debris cloud growing exponentially until escaping gravity's pull becomes mathematically impossible. No more GPS, no weather satellites, no international space station, just an ever-thickening swarm of metal teeth grinding away at anything daring to leave the atmosphere. We've already seen glimpses of this future. In 2009, a defunct Russian satellite collided with an active American one, instantly creating over 2,000 trackable fragments and countless smaller, undetectable ones. Each piece still orbits today, some crossing paths with operational satellites dozens of times daily. The European Space Agency now maneuvers its satellites weekly to avoid collisions, like a driver swerving through highway traffic blindfolded. But here's the real horror. Even if humanity stopped all space launches tomorrow, the existing debris would keep colliding, propagating the cascade for centuries. Simulations show certain orbital altitudes could become impassable within decades, stranding future generations beneath an impenetrable ceiling of junk. Imagine explaining to your grandchildren why Mars colonies exist only in history books because we littered our celestial doorstep so recklessly, the door slammed shut forever. Yet there's a cruel irony in this scenario. The same ingenuity that created spaceflight might be our only salvation. Scientists are testing debris catchers, nets, harpoons, even lasers to nudge fragments into decaying orbits. Private companies experiment with satellite graveyard orbits, while others design self-destructing spacecraft that vanish after use, but the clock is ticking. Every new satellite we launch is both a tool and a potential weapon in this high-stakes game. The difference between a functioning space age and Kessler's nightmare comes down to one question: can we clean up faster than we pollute? The answer will determine whether humanity remains a single-planet species, or whether we condemned ourselves to solitary confinement in the very moment we reached for the stars. A neutron star is already one of the most extreme objects in the universe, but a magnetar takes that terror to unimaginable levels. Imagine the core of a collapsed star so dense, a teaspoon of its material would weigh 1 billion tons on Earth. Now amplify its magnetic field to a level that defies reason quadrillions of times stronger than our planet's protective shield. That's a magnetar, a cosmic monster capable of rewriting the laws of physics within its reach. At half the distance between Earth and the Moon, its magnetic field would erase the data from every credit card on the planet. But step back even further, light years away, and the nightmare truly begins. A magnetar's magnetic field doesn't just distort atoms, it twists them. The very electrons orbiting atomic nuclei would be stretched into needle-thin lines, dismantling matter at the subatomic level. A planet caught in the crossfire wouldn't explode or implode. It would unravel, its atmosphere and crust peeling away like layers of an onion, stripped atom by atom into a dispersed cloud of ionized particles. We've witnessed magnetar fury firsthand. In 2004, a flare from SGR 180620, a magnetar 50,000 light-years away, compressed Earth's magnetic field so violently it briefly ionized our upper atmosphere despite being halfway across the galaxy. If this same flare had originated within 10 light-years of Earth, it would have scoured our ozone layer into oblivion, triggering mass extinctions under an unfiltered cosmic radiation bath. The mechanics behind these storms are even more unsettling. When a magnetar's crust fractures under unimaginable internal stresses, it releases starquake seismic events that ripple across its surface, snapping magnetic field lines like overstretched rubber bands. The energy released in these events can outshine our entire galaxy for a fraction of a second. A blink and you'll miss it apocalypse visible across the universe. What's left behind is a labyrinth of rebounding magnetic waves crisscrossing space with lethal efficiency. Yet here's the paradox: magnetars might also be cosmic lifelines. Their intense magnetic fields are thought to forge heavy elements like gold and platinum, scattering them into space through violent eruptions. The very forces that could erase a world from existence also seed future solar systems with the building blocks of life. It's a brutal reminder that destruction and creation are two sides of the same coin in the cosmos, and that the most terrifying forces in the universe might also be the most necessary. For now, the closest known magnetar sits safely distant at 13,000 light-years away. But the galaxy is littered with these dormant time bombs, each one a silent testament to nature's capacity for extremes. Their existence forces us to confront an uncomfortable truth. The universe doesn't just contain danger, it weaponizes the very fabric of reality itself, turning physics into a force of annihilation. And magnetars, they're the ultimate proof that in the grand cosmic arena, we're not just spectators, we're potential targets. The universe isn't just expanding, it's accelerating, a runaway cosmic engine fueled by something we barely understand: dark energy. And if this mysterious force grows stronger over time, it won't just stretch space, it will win a tug of war against gravity, electromagnetism, even the bonds holding atoms together. This is the Big Rip, a doomsday scenario where the fabric of reality itself is shredded in a slow-motion apocalypse. First, the galaxies vanish. As expansion accelerates, distant star systems blink out one by one, their light stretched beyond detectability. The Milky Way's local group might cling together briefly, but eventually, even Andromeda, our future collision partner, is wrenched away, disappearing into the void like a ship swallowed by fog. Next, gravity loses its grip, stars slip from their galaxies, planets abandon their orbits, and solar systems dissolve into wandering husks. The night sky, once crowded with neighbors, becomes a wasteland of isolated sparks. Then comes the true horror: the universe turns on itself. As expansion outmuscles atomic forces, planets crack apart like dry clay. Earth's crust peels away, its fragments hurled into darkness faster than the speed of light. The sun unravels, its plasma scattered across an infinite gulf. Finally, in the last microseconds, atoms, the building blocks of everything, are torn asunder. Protons and electrons, separated by an unstoppable tide of stretching space, cease to interact entirely. Reality doesn't end with a bang or even a whimper. It ends with silence as every particle becomes an island, alone in an ever-widening sea of nothingness. The timeline, it could be tens of billions of years, or much sooner if dark energy behaves unpredictably. Some models suggest a mere 60 billion years before the rip reaches its gruesome crescendo. That sounds distant, but consider this: the universe is already pulling the trigger. We've measured galaxies receding faster and faster, their light red shifting into oblivion. The Big Rip isn't science fiction, it's the logical endpoint of forces already in motion. Yet here's the cruelest twist: unlike other cosmic doomsdays, there's no surviving this one. No bunker, no escape. The rip doesn't just destroy, it erases the very concept of together. No two particles will ever interact again. No memory, no legacy, just infinite, irreversible isolation. The universe began with a singularity. It might end with the opposite, an eternity of fragments, each unaware the others ever existed. Dark energy remains a mystery, but its implications are clear. The cosmos isn't just indifferent to our existence, it's capable of unraveling it completely. And while the Big Rip may loom far in the future, it forces us to confront a chilling truth. The universe isn't built to last, it's built to disintegrate. Rogue planets don't orbit stars, they drift through the void like cosmic nomads, untethered from the warmth of any sun. Astronomers estimate trillions of these frozen outcasts exist in our galaxy alone, ejected from their home systems by gravitational chaos or born in the cold darkness between stars. Some, like PSO-J3 18.522, glide through space just 80 light-years from Earth, a world so isolated it took scientists years to confirm it wasn't a failed star or a distant galaxy, just a solitary planet adrift in the endless night. The horror of rogue planets isn't just their loneliness, it's what might linger beneath their icy surfaces. Cut off from starlight, these worlds shouldn't harbor life as we know it, yet some defy expectations. Take PSO-J3 18.522. Though it's younger than most planets, its atmosphere still swirls with violent storms and molten heat from its violent birth. Deep underground, tidal forces or radioactive decay might maintain vast subsurface oceans, hidden pockets of liquid where extremophile organisms could cling to existence. Imagine entire ecosystems frozen in time, trapped beneath miles of ice, unaware their world was hurled into the abyss eons ago. Then there's the sheer scale. Supercomputer simulations suggest rogue planets could outnumber stars in the Milky Way by 100 to 1 dark, untracked giants drifting unseen between solar systems. Some might even be interstellar arcs carrying the last remnants of dead civilizations. Picture a planet like Earth, wrenched from orbit during a close encounter with a passing star, its oceans freezing solid over millennia as it wanders farther into the void. Any survivors would watch their sun shrink to a pinpoint, then vanish entirely, leaving only the dim glow of radioactive core vents to sustain them in perpetual night. But the true terror comes when one intrudes on our cosmic neighborhood. Rogue planets don't announce their approach, no light, no heat signature, just a subtle gravitational whisper. If one passed through the outer solar system, its pull could disrupt the Oort cloud, flinging comets inward in a deadly barrage. Worse yet, direct contact could destabilize planetary orbits, nudging Earth into a deeper freeze or a lethal plunge toward the Sun. And here's the cruel twist: we'd have almost no warning. Current telescopes might spot a nearby rogue planet only years before its gravity began rewriting the rules of our celestial dance. Yet these orphans of the cosmos might also be our salvation. Some scientists speculate rogue planets could serve as way stations for future interstellar travel, rest stops in the darkness, their frozen resources mined for fuel or shelter. Others imagine them as time capsules, preserving ancient chemical signatures from the early universe, clues to how planetary systems form. Their very existence forces us to reconsider what a planet even is. Not just objects bound to stars, but free-floating worlds with their own stories of exile and survival. So while rogue planets might be relics of cosmic violence, they're also proof of the universe's boundless creativity. For every stable system like ours, there are countless others torn apart, their pieces scattered across the galaxy like seeds in the wind. And somewhere out there, in the infinite cold, another PSOJ3 18.522 is drifting, carrying its secrets, its scars, and perhaps, just perhaps, the faintest whisper of life clinging on against all odds. On December 27, 2004, Earth was bathed in a silent scream from across the galaxy, an invisible tsunami of radiation so powerful it compressed our planet's magnetic field like a soda can. Originating 50,000 light-years away from a magnetar called SGR 180620, this gamma-ray burst lasted just 0.2 of a second, yet in that blink of cosmic violence, it released more energy than our Sun will emit in 100,000 years. Satellites choked on the particle storm, radio communications faltered, and the ionosphere, the protective layer shielding us from solar radiation, temporarily warped under the assault. All this from an explosion halfway across the Milky Way. Now imagine if it had happened next door. A gamma-ray burst within 10 light-years wouldn't just distort our atmosphere, it would obliterate it. The initial flash would blind anyone facing its direction, retinal burns searing through closed eyelids. Within hours, high-energy particles would shred the ozone layer, exposing every living thing to lethal ultraviolet radiation. Crops would wither under the unfiltered solar onslaught, ecosystems collapsing as DNA unraveled at the cellular level. The sky itself would glow with eerie auroras, not just at the poles but worldwide, a beautiful, deadly testament to the irradiated air we'd now be breathing. And that's just the opening act. The real nightmare begins weeks later, when nitrogen oxides formed in the irradiated atmosphere trigger acid rain potent enough to dissolve leaf tissue and poison freshwater supplies. Global temperatures would plummet as sunlight scattered through the newly hazy sky, mimicking a nuclear winter without a single warhead fired. Fossil records suggest this might have happened before the Ordovician extinction 450 million years ago, where 60% of marine life vanished, coincides with suspicious traces of gamma-ray byproducts in ancient rock layers. If true, it means Earth has already endured, and barely survived, a cosmic apocalypse by fire and ice. But here's the twist: gamma-ray bursts aren't random accidents. They're the death throes of hypermassive stars collapsing into black holes, or the merger of neutron stars, events so cataclysmic they beam their fury into narrow, focused jets. Like a cosmic sniper rifle, these beams only devastate what lies directly in their path. Earth could be annihilated by a burst in another galaxy, while planets just a few degrees off the kill zone remain untouched. It's not about distance, it's about alignment, and given the thousands of bursts detected yearly, the question isn't whether another will strike, it's when and how close. Yet even in this horror lies a strange cosmic mercy. Short bursts from colliding neutron stars forge heavy elements like gold and platinum, scattering them into space to seed future planets. The same forces that could sterilize a world also gift it the building blocks of life. Gamma-ray bursts don't just destroy, they create, weaving destruction and renewal into the universe's grand tapestry. For now, we orbit safely outside any known kill zone, but the universe has a way of reminding us survival isn't guaranteed. It's borrowed time, measured in the intervals between stellar screams. The dark flow isn't just a mystery, it's a cosmic anomaly so bizarre, it defies everything we thought we knew about the universe's structure. Imagine billions of galaxies, each weighing as much as 1,000,000 billion suns, all drifting in the same direction like leaves caught in an invisible river. This isn't random motion, it's a synchronized march toward something we can't see, something beyond the edge of the observable cosmos. Astronomers call it the dark flow, and its existence suggests forces at work so vast they rewrite the rules of reality itself. The discovery came from studying galaxy clusters, colossal structures bound by gravity, using the cosmic microwave background as a reference. Scientists expected these clusters to move randomly, their motions balanced by the universe's expansion. Instead, they found hundreds of them streaming toward a single point in space near the constellations Centaurus and Vela, racing at speeds exceeding 1,000 kilometers per second. The scale is staggering. This flow extends over billions of light years, encompassing regions so distant their light hasn't had time to reach us since the Big Bang. Whatever's pulling them lies beyond the cosmic horizon, in realms we'll never see. Theories range from the unsettling to the apocalyptic. Some suggest the dark flow is the gravitational tug of a supermassive structure, a supervoid, or even another universe brushing against ours in the multiverse's foam. Others propose it's evidence of a cosmic defect, a scar left over from the birth of spacetime, warping the fabric of reality like a tear in a spiderweb. The most haunting possibility, that our universe isn't uniform at all, that we're just a small pocket of spacetime caught in the wake of something incomprehensibly larger, a cosmic riptide dragging us toward an unfathomable destiny. What makes the dark flow truly terrifying isn't just its scale, it's the implication that we're not the center of anything. The universe might have a true north, a directionality that renders our maps meaningless. If galaxy clusters are being pulled, then the forces shaping the cosmos aren't just impersonal, they're actively organizing it, herding matter like cattle toward some distant dark harvest. And we're caught in the current, helpless to resist or even understand the destination. Yet here's the twist, the dark flow might also be a clue. If it's caused by a neighboring universe, it could be our first tangible evidence of the multiverse, a reality where our cosmos is just one bubble among infinite others. The flow wouldn't be a threat then, but a lifeline, a thread tying us to a grander structure we're only beginning to glimpse. But until we know for sure, the dark flow remains one of cosmology's greatest enigmas, a silent, relentless reminder that the universe is stranger and far less knowable than we ever dared to dream. Every second, trillions of invisible bullets tear through your body, silent, unstoppable, and utterly indifferent to your existence. These are neutrinos, the universe's ghost particles, born in the nuclear furnaces of stars and the cataclysmic deaths of supernovas. So tiny they barely interact with matter, they pass through planets like light through glass, leaving no trace. But sometimes these phantoms reveal their lethal potential, and when they do, the results are terrifying. Take supernova 1987A, the closest stellar explosion witnessed in modern history. When it detonated in the Large Magellanic Cloud, telescopes captured the light show, but the real horror arrived hours earlier in the form of a neutrino burst. 24 particles were detected across 3 underground observatories, a whisper of the trillions that actually rained down on Earth. Each one carried enough energy to punch through solid lead, their combined force briefly outshining every star in the universe combined. Had the supernova been closer, say, within 30 light-years, those same neutrinos would have delivered a radiation dose equivalent to 50,000 chest X-rays per second, cooking every living thing from the inside out. What makes neutrinos so insidious is their sheer abundance. The Sun alone bombards every square centimeter of Earth with 65 billion neutrinos per second. Your thumbnail just got pierced by millions while you read this sentence. Normally harmless, their near-massless nature lets them ignore the electromagnetic forces that stop other particles dead. But in extreme densities, like those near a collapsing star, the odds shift. A supernova's core releases so many neutrinos, they briefly outnumber all the atoms in the visible universe. Packed together, these ghosts gain substance enough to transfer lethal energy to human tissue, disrupting cellular machinery with quantum precision. The horror isn't just in their lethality, it's in their silence. A nearby supernova's neutrino wave would strike hours before the light, giving zero warning. One moment you're fine, the next your DNA is riddled with breaks from particles you can't see, feel, or block. No shelter would help neutrinos penetrate Earth's entire diameter like it's not even there. The only mercy is distance. For now, the closest supernova candidate, Betelgeuse, sits safely 640 light-years away. But the cosmos is unpredictable. A hidden dying star closer than we've mapped could already be priming its neutrino gun, and we wouldn't know until the ghost bullets were already inside us. Yet neutrinos aren't just harbingers of doom. They're cosmic messengers carrying secrets from the universe's most violent events. By studying them, we've peered inside the sun's core, confirmed the dynamics of supernovas, and even glimpsed the physics of the Big Bang. Their very elusiveness makes them invaluable, the universe's perfect spies, slipping through borders no other particle can cross. So while neutrino radiation might spell doom in one scenario, it's also a key to unlocking the cosmos. The same ghosts that could kill us also help us see. Some cosmic mysteries don't whisper, they scream. The Red Rectangle Nebula, a bizarre structure 1,300 light-years from Earth, glows with geometric precision so unnatural it looks like a celestial cathedral built by giants. At its core, an eerie X shape stretches outward, its beams intersecting with razor-straight symmetry, defying every law of how nebulae should form. This isn't the chaotic aftermath of a dying star. It's geometry carved into the fabric of space itself, a cosmic message written in angles and light. Most planetary nebulae, the glowing shells of dying stars, resemble tangled spiderwebs or delicate bubbles. But the Red Rectangle, its twin cones of dust and gas align with impossible precision, each side mirroring the other like a meticulously crafted stained glass window. Astronomers first blamed it on a dense dust disk surrounding the central star, HD 44179, but simulations couldn't replicate the X's crisp edges. The structure's sharpness suggests something more: unsettling forces sculpting matter with unnatural control. Enter the alien megastructure hypothesis. While most scientists attribute the shape to complex stellar winds and magnetic fields, the Red Rectangle's precision has sparked darker theories. What if those beams aren't natural at all? On Earth, we recognize intelligent design by its symmetry: pyramids, skyscrapers, radio towers, all bearing the fingerprints of intention. Could the X be a beacon, a monument, or even the ruins of some unfathomable engineering project? The nebula's central star, a binary system, adds fuel to the fire. Two stars locked in a gravitational dance might provide the energy a civilization would need to reshape their celestial neighborhood. Yet the true horror lies in the light itself. The Red Rectangle glows with an eerie red hue, not from heated gas, but from a phenomenon called extended red emission, a spectral fingerprint still poorly understood. Some researchers speculate the glow comes from complex organic molecules, polycyclic aromatic hydrocarbons floating in the dust. These are the same building blocks of life found in meteorites and comets. So beneath the nebula's geometric perfection might swirl the raw ingredients of biology, a cosmic kitchen where the recipes for existence are written in chemistry and geometry. The Red Rectangle won't last forever. In a few thousand years, its delicate structure will dissipate, leaving only a white dwarf cooling in the void. But for now, it hangs in the sky like a question mark etched in fire, a reminder that the universe doesn't just create chaos. Sometimes it drafts blueprints. Whether those blueprints were drawn by nature or something else, that's a mystery not even the stars are willing to answer yet. The Milky Way isn't drifting through space, it's being pulled, an entire galaxy caught in the grip of something colossal and unseen. 14 million miles per hour, that's the speed at which our cosmic home, along with hundreds of thousands of other galaxies, is hurtling toward a gravitational nightmare known as the Great Attractor. Lurking in the constellation Centaurus, this invisible behemoth exerts a pull so immense, it bends the trajectories of galaxies across a quarter of the observable universe. But here's what chills astronomers to the bone. We can't see what's doing the pulling. The Great Attractor lies hidden behind the Milky Way's own galactic plane, a region so dense with stars and dust. It's called the zone of avoidance, not just because it's hard to observe, but because it actively resists our attempts to understand it. For decades, this cosmic blind spot kept the Great Attractor's secrets locked away. Even X-ray telescopes struggled to pierce the veil, leaving scientists to theorize about the unseen mass warping spacetime on such a staggering scale. Then, in the 1990s, infrared observations revealed the horrifying truth. The Great Attractor isn't the end of the line, it's just a waypoint. Our galaxy, along with the entire Laniakea supercluster, a web of 100,000 galaxies spanning 500 million light-years, is being dragged towards something even larger. Dubbed the Shapley Attractor, this monstrous concentration of mass, 8 times denser than average, sits 650 million light-years away, a gravitational lighthouse pulling the cosmos toward its event horizon. The scale of this motion defies comprehension. Picture a river of galaxies, each weighing hundreds of billions of suns, all flowing toward the same cosmic drain. The Virgo cluster, the Hydra Centaurus supercluster, even the Milky Way, we're all caught in the current, helpless against the tide. But the real terror lies in the unanswered questions. What happens when we get there? Collisions between galaxy clusters unleash energies that make supernova look like firecrackers, triggering shock waves of hot gas and dark matter capable of rewriting entire cosmic neighborhoods. And if the Great Attractor is just a stepping stone to Shapley, what other horrors lie beyond, in the darkness we can't yet see? Yet there's a strange beauty in this mystery. The Great Attractor forces us to confront how little we truly know about the universe's structure. It's a reminder that even the mightiest galaxies are just leaves on a cosmic stream, subject to forces we're only beginning to map. One day, advanced telescopes might peel back the zone of avoidance, revealing the monsters lurking in the shadows. Until then, the Great Attractor remains a silent, irresistible force, a gravitational siren calling us toward a future we can't yet fathom. Black holes don't just kill, they perform a slow, grotesque ballet of annihilation, stretching the very concept of death into something far more sinister. Spaghettification isn't just a whimsical term, it's the universe's most violent cooking show, where gravity's tidal forces stretch matter into molecular noodles. Picture this, your falling feet first toward a stellar mass black hole. At first, it's almost peaceful, a silent drift into darkness. Then, the differential gravity takes hold. Your feet, closer to the singularity, feel a tug exponentially stronger than your head. The stretching begins subtly, a faint pull like taffy warmed by the sun. But within seconds, the force multiplies, muscles tear, bones splinter. Your body elongates into a grotesque ribbon of flesh and bone, thinning into a single strand of atoms stretched across the void. Time twists the knife. As you fall deeper, relativistic effects warp your perception. Seconds for you stretch into years for outside observers. You'd watch the universe age in fast-forward, stars dying, galaxies colliding, while your final moments play out in agonizing slow motion. Even light betrays you, bending into a horror movie lens effect. Your distorted limbs would appear to freeze at the event horizon, a ghostly afterimage burning into space-time like a cosmic fossil. The physics is crueler than fiction. A black hole with the mass of our sun would spaghettify you before you crossed the event horizon, turning you into a screaming poster strand with full awareness of the process. But a supermassive black hole, that's where the real nightmare begins. Its gentler tidal forces mean you'd slip past the event horizon intact, only to be shredded from the inside out by growing gravitational gradients. Imagine feeling your cells unravel, your thoughts stretching into incoherent static as your very electrons are ripped from their orbits. Yet here's the cosmic irony. From the outside, no one would see the gore. Your stretched remains would redshift into invisibility, your final scream silenced by the laws of physics. Black holes don't just consume matter, they erase the evidence, leaving no trace of the horrors within. It's the universe's perfect crime scene, a murderer that swallows the victim, the weapon, and even the memory of the act. And somewhere out there, right now, this fate is playing out in real time. Stars, planets, perhaps even entire civilizations twisted into oblivion by forces beyond comprehension. Spaghettification isn't just a theoretical curiosity. It's a reminder that the universe doesn't just kill, it designs its executions. On August 15, 1977, a radio telescope at Ohio State University picked up a signal so powerful, so perfectly aligned with what scientists predicted an alien transmission would look like, that astronomer Jerry Rutter scrawled, "Wow." In the margins of the date, a printout giving birth to one of the most haunting mysteries in the history of astronomy. 72 seconds. That's how long the signal lasted. A narrowband radio burst 20 times louder than the cosmic background noise, pulsing at exactly the frequency hydrogen resonates in space, 1420 MHz. The universe's most common element, the logical choice for a beacon. It wasn't random static or a passing satellite. It came from the direction of the constellation Sagittarius, where no known human-made objects were transmitting, and it matched every theoretical profile of an intentional extraterrestrial signal. Then, as suddenly as it appeared, it vanished, never heard again. 47 years of searches with increasingly sensitive equipment have turned up nothing. No repeats, no variations, no traces. And that absence is what chills researchers to the bone. Natural cosmic phenomena don't just wink out of existence without a trace. Pulsars repeat, quasars flicker. Even the most energetic bursts, like colliding neutron stars, leave afterglows. The wow signal didn't just defy expectations, it defied the laws of probability. Statistically, a one-off event that precise should be impossible, unless, of course, it wasn't natural at all. Theories range from the tantalizing to the terrifying. Some suggest it was a military transmission, though no nation has claimed it. And why broadcast from deep space? Others propose it was a comet's hydrogen cloud reflecting radio waves, except the signal's frequency and stability don't match known cometary behavior. Then there's the darkest possibility, that we intercepted a single, fleeting whisper from a civilization that no longer exists. A distress call, a final broadcast. A beacon switched on just long enough to sear its presence into our records before silence reclaimed the cosmos. Consider the timing. The signal arrived during humanity's narrow technological window, after we'd built radio telescopes sophisticated enough to hear it, but before we'd expanded our listening capacity enough to pinpoint its origin. A delay of just a few decades in our advancement, and we might never have detected it at all. That chilling coincidence raises a haunting question. Was the wow signal a cosmic test, one we failed? If it was intentional, the sender might have expected a response, a confirmation that someone was listening. Instead, we spent years debating its origin, unable to muster a reply before the opportunity slipped away forever. The wow signal's legacy isn't just a mystery, it's a mirror. It forces us to confront how fragile our connection to the universe really is. A single, unverified blip on a printout might be our only brush with extraterrestrial intelligence. Or the first faint ripple of a conversation we're only beginning to understand. Either way, its silence echoes louder than any signal, because in the vast, indifferent cosmos, the most terrifying possibility isn't being watched. It's being noticed and then ignored. In October 2017, astronomers spotted something streaking through our solar system that defied all expectations. A visitor from the stars tumbling end over end at blistering speeds. They named it Oumuamua, Hawaiian for scout or messenger, but this cosmic wanderer carried more mysteries than anyone anticipated. shaped like a flattened cigar or a pancake, estimates vary wildly. Its dimensions alone raised eyebrows, roughly 400 meters long but only 40 meters wide, a geometry unlike any known asteroid or comet in our solar system. But the real shock came when Oumuamua did something impossible. It accelerated. Gravity alone couldn't explain the sudden speed boost as it slingshotted past the sun. Comets gain momentum from outgassing icy material vaporizing in sunlight, yet Oumuamua left no visible tail or debris cloud. Infrared scans detected no heat signature, no water, no carbon dioxide, nothing to account for the thrust. It moved like a spacecraft firing invisible engines. Harvard astrophysicist Avi Loeb seized on the anomaly, proposing a radical theory. Oumuamua wasn't a rock. It was alien technology, a solar sail or probe discarded or drifting, its thin profile optimized for interstellar travel. Mainstream science pushed back hard. Alternate explanations ranged from exotic hydrogen ice evaporation, a phenomenon never observed but theoretically possible, to the object being a shard of a Pluto-like planet fractured by some ancient collision. Critics argued that invoking aliens violated Occam's razor, the principle that the simplest explanation is usually correct. But Loeb countered with a devastating point. Since when is assuming we're alone in the universe the simpler answer? Humanity's history is littered with dismissing the unfamiliar as impossible, only to be proven wrong. The data leaves unsettling gaps. Oumuamua's brightness fluctuated by a factor of 10 as it rotated, suggesting an irregular, possibly metallic surface reflecting sunlight unevenly. Its trajectory didn't match any known origin point within our galaxy, implying an interstellar journey lasting millions of years. Most damning, we'll never get another look. By the time telescopes spotted it, Oumuamua was already racing away, too distant for follow-up observations. All we have is a handful of data points, and the haunting possibility that we brushed shoulders with something engineered, not born. Whether artifact or oddity, Oumuamua exposed how unprepared we are for interstellar visitors. Future telescopes might catch the next one sooner, but for now, this silent scout remains a riddle. A natural anomaly stretching the limits of physics or evidence that we're not the only ones reaching for the stars. Either answer rewrites our place in the cosmos. And that's the true terror, not knowing whether the universe is merely strange or watching us back. Deep in the heart of modern cosmology lies a contradiction so profound, it threatens to unravel our understanding of the universe itself. The Hubble constant, a number meant to tell us how fast the cosmos is expanding, has become the center of a crisis, one where the laws of physics as we know them might be fundamentally broken. On one side, we have meticulous measurements from the cosmic microwave background, the afterglow of the Big Bang, suggesting an expansion rate of roughly 67 kilometers per second per megaparsec. On the other, observations of pulsating stars and supernova in our galactic neighborhood point to a faster pace, 73. The difference might seem small, but in the unforgiving precision of astrophysics, it's a chasm. This isn't just a calculation error or a blip in the data. These measurements come from two of the most trusted methods in science, each backed by decades of refinement, and yet they refuse to agree. The implications are staggering. If both are correct, then something is missing from our equations, something massive. Either dark energy isn't behaving the way we think, gravity itself works differently on cosmic scales, or the fabric of reality is changing over time. The most unsettling possibility, that the universe isn't just expanding, it's accelerating unpredictably, like a car whose gas pedal is being pressed harder by an invisible force we can't account for. Take the cosmic microwave background, our snapshot of the infant universe. It tells a story of a cosmos shaped by dark matter and dark energy, with expansion unfolding in predictable ways. Yet when we look at nearby stars and galaxies, their motions tell a different tale, as if the universe has decided to speed up without warning. It's like watching a tree grow at one rate in its early rings, only to find its outer bark expanding faster than the roots could ever support. One explanation: dark energy isn't constant but evolving, growing stronger over time. If true, the fate of the universe could be far more violent than the slow fade of the Big Freeze instead. A Big Rip scenario where galaxies, stars, and even atoms are torn apart by runaway expansion. Then there's the rogue variable no one wants to confront. What if our models of gravity are wrong? Einstein's theory of general relativity has survived every test for over a century, but what if it starts to fray at the edges when applied to the universe as a whole? Modified gravity theories whisper of unseen dimensions or hidden forces, but they remain controversial, patching one hole while tearing open others. The Hubble constant crisis doesn't just challenge our tools, it challenges our confidence in the bedrock of physics itself. Here's where the real horror sets in. If we can't reconcile these numbers, it means the universe is playing by rules we haven't discovered yet. Every measurement, every equation, every prediction about the cosmos's fate could be built on sand. The Hubble constant isn't just a number, it's a mirror reflecting how much we still don't understand. And until we solve it, we're left staring into the abyss, wondering if reality is far stranger, far less predictable than we ever dared to imagine. Death should be final, but quantum mechanics whispers a loophole, one where you might never experience your own end. This is the quantum immortality paradox, a thought experiment so unsettling, it forces us to confront whether consciousness itself could cheat death across infinite realities. Picture this: every decision, every random quantum event spawns branching universes, countless versions of you living out every possible outcome. Now imagine standing in front of a gun. In most timelines, the trigger pulls and that's the end. But in a vanishingly small number, the gun jams, a passerby intervenes, or the bullet deflects. The odds are astronomically against you, but if even one universe exists where you survive, your subjective experience would only continue there. The horror deepens when you realize this applies to all mortal risks. Car crashes, terminal illnesses, even the heat death of the universe statistically, some version of you would persist through increasingly improbable escapes. Aging, there's a reality where your cells regenerate just enough to keep you alive. A supernova vaporizing Earth, one universe's physics bends to shield you as you drift into the void. The paradoxical result: you'd experience yourself as the luckiest being in existence, surviving against all logic while watching others perish around you. Critics dismiss this as a sleight of hand. Consciousness isn't a spotlight jumping between timelines. They argue just parallel versions unaware of each other. Yet the math holds eerie implications. In a multiverse, the probability of finding yourself in any specific timeline approaches zero except for the ones where you're still alive to observe it. Your continued existence becomes a grotesque statistical inevitability, like rolling a billion-sided die and always landing on the one surviving face. The true terror lies in the endpoint, not survival but isolation. As universes decay into entropy, the branches where you persist grow ever lonelier. Imagine outliving stars, then galaxies, then reality itself, trapped in a solitary pocket of space-time where quantum fluctuations keep your neurons firing long after the cosmos has cooled to absolute zero. You wouldn't cheat death, you'd become its final witness, a flickering ember in an infinite graveyard of collapsed possibilities. Quantum immortality isn't a gift. It's a prison sentence written into the fabric of existence, where the universe doesn't let you die but forgets to let you live. For decades, conspiracy theorists have whispered about an ancient sentinel silently orbiting Earth, a mysterious object dubbed the Black Knight satellite. Lurking in the shadows of space since before human civilization began, this enigmatic structure allegedly broadcasts strange signals while watching us with unknowable intent. Some claim it's a 13,000-year-old alien probe left behind by an advanced race to monitor our evolution. Others insist it's proof of lost human technology from Atlantis or some forgotten pre-flood civilization. The stories ripple through UFO circles with all the drama of a sci-fi thriller, except none of it is true. The myth began with misunderstood science. In 1954, newspapers reported that Donald Keyhoe, a former Marine Corps pilot and UFO researcher, claimed the U.S. Air Force had detected a mysterious satellite orbiting Earth years before Sputnik launched. The story snowballed. Nikola Tesla's supposed reception of repeating radio signals in 1899 got folded into the legend, along with grainy NASA photographs from the 1990s showing unidentified debris during shuttle missions. These fragments of fact twisted into fantasy, weaving a tale of an extraterrestrial artifact hiding in plain sight. But the truth is far more unsettling, because while the Black Knight isn't alien, it is a ghost. Modern astronomers confirm Earth is surrounded by a graveyard of space debris, defunct satellites, discarded rocket stages, and fragments from collisions, all silently tumbling through orbit. Some of these objects do behave strangely, reflecting light in odd ways or spinning unpredictably. The Black Knight images likely just a thermal blanket lost during a spacewalk, its wrinkled surface catching sunlight at eerie angles. The real horror isn't a phantom satellite, it's our own echoing solitude. The Black Knight myth persists because we want to believe something watches us, that we're not alone in the cosmos. But the silence beyond Earth's orbit is deafening. The universe doesn't need alien sentinels to frighten us. The endless dark, punctuated only by the skeletal remains of our own discarded machinery, is terrifying enough. We built the ghosts we feared, and they're still up there, circling, waiting not for contact, but for the inevitable decay of their orbits, when they'll finally burn up and vanish, leaving no trace behind. So here we stand at the edge of the abyss, having counted 25 ways the universe could erase us, not with malice, but with indifference, the Boötes Void's yawning nothingness. Rogue black holes drifting unseen like celestial landmines, galaxies cannibalizing each other in slow motion, zombie stars resurrected from their own corpses. The Fermi Paradox's deafening silence, hinting at civilizations snuffed out before they could scream. Dark matter's invisible web pulling strings we can't even see. Quasar death beams that could sterilize worlds in an eye blink. Vacuum decay unraveling reality itself. Each horror peels back another layer of cosmic fragility, revealing how precariously we cling to existence in a cosmos that doesn't care. These aren't just threats, they're revelations. Every anomaly, every paradox forces us to confront how little we truly understand. The wow signal's fleeting whisper. Oumuamua's impossible acceleration, the great attractor dragging us toward something unseen. Even our own satellites orbiting Earth, mistaken for ancient watchers because we ache for meaning in the void. The universe isn't just stranger than we imagined, it's stranger than we can imagine, a Lovecraftian tapestry of forces and phenomena that dwarf human comprehension. And yet here we are, alive, observing, reaching for answers even as the cosmic deck stacks against us. That's the paradox of the dark universe. The same forces that could annihilate us also forged the atoms in our bones. Supernova seeded the iron in our blood. Neutrino ghosts carry secrets from stellar graves. The very laws that might one day tear reality apart are what allowed life to spark in the first place. So what do we do with this knowledge? We keep looking, keep questioning, because the greatest horror isn't the darkness, it's stopping the search. The moment we turn away from the void, we admit defeat. And humanity, we've never been good at surrender. If this journey through the cosmos's nightmares left you equal parts thrilled and unsettled, you're not alone. Click like if you want to dive deeper, because this is just the beginning. Part 2 awaits, where we'll expose even darker truths lurking beyond the edge of understanding. And if you haven't already, hit subscribe. The universe has infinitely more terrors to unveil, and you won't want to miss them. Until then, remember, the stars may be beautiful, but they don't shine for us. The cosmos is vast, ancient, and utterly indifferent. And that's what makes every moment we steal from the void, every question, every discovery, a rebellion against the dark. See you in the next universe.